Hey there, TouchDesigner developers. Welcome to another TouchDesigner tutorial. This video is going to be a follow-up from my previous video, which taught you how to create or recreate a spirograph in TouchDesigner. If you haven't seen that already, make sure to check it out on my channel. It's just called Recreating a Spirograph in TouchDesigner. If you're watching this video right now, you can just click on my channel page and check that out first. Basically, we're going to use the exact network that we create in that video as a starting point, and I'm going to go over a couple of notes about that network after I've been looking at it a little bit more, and we're going to add some new functionality to it that'll get us even closer to having an exact replica of what the functionality of that Spirograph toy is able to do with pen and paper. Okay, so before we get started with the updates to our network, I wanted to go through a couple of discoveries that I made and changes to the original method that I made due to some of the features basically being unnecessary after I had gone through certain experiments in the process of putting this thing together. The first thing that I wanted to mention is that the original way that I had set up this feedback loop basically had the order of operators into this composite set so that the feedback loop was on top of the original image coming in. And basically what that means is when the drawing is complete like this, the current position of the line, which is still drawing, is not really visible because it's happening underneath the drawing that's already on the screen. So if you were to come into this composite top and then flip the order that these two operators are connected, you could actually see the current position of that line being drawn, and it would add to the image. So that's not something you necessarily have to do, but I wanted to show you that that's possible. And when that is done, you can see it just added a new green line over top of some of the old parts of the drawing. So you can have it basically continue to draw over the image that has already been created if you set it that way. Two settings that I think are kind of redundant and unnecessary. I had set the pixel format of the noise top that fed the constant mat for this material SOP. I'd set the pixel format to 16-bit because in my experiments I had been messing around with a bunch of different things and had some issues with color banding. But in the final version that we came up with here, I think that even at the 8-bit default pixel format for this noise top, you can still get an image that doesn't have that color banding issue. I think this was only due to the way that I had originally come up with doing this network. So you can go ahead and change that pixel format mode for this noise top to the use input or the 8-bit fixed mode, and you should get results that are basically the same as what you see already. The second pixel format setting that I think is unnecessary, at least with the way that the network is set up by default, is the pixel format that we set within our render top. The render top I had set to 16-bit because I'd been experimenting with opacity changes within the feedback loop. So I was having the drawing basically fade out over time, and without the 16-bit pixel format, when you do that, it will never fade completely out to zero. You'll have this kind of residual transparent leftovers from the image that was on the screen. So I'd set it to 16-bit for that reason. However, since we're not actually doing any opacity changes in the default version of this network, I don't really think it's necessary to have that 16-bit float mode set. And when you're using a computer that is not modern in its capabilities like the one that I'm using, sometimes these pixel format mode changes can actually give you a better and faster performance. So I'd recommend just doing that if you're not going to be needing them. So again, if you're not going to be working with those opacity changes in the feedback loop, you should be okay using the use input or 8-bit fixed pixel formats. Other than that, the light, I had everyone transform the position of the light because as I was experimenting with the original iterations before the video that I'd made, I'd use the lighting, and it actually had an effect on the stuff that I'd been displaying on screen. But since we are using a constant material, a constant matte, the light actually has no effect on our output image. You could set this position to anything you want and it will not change the colors or anything within our image on screen. So you actually don't have to worry about messing with the transform of the light at all unless you were using a different material shader for your SOP network. So I just thought I would point that out. So the last thing that I experimented with and found some alternate settings for was the speed settings within the very beginning of our network here, which are governed by this constant chop. After experimenting with it and not doing screen recording at the same time, I found that on my computer, a lot of the jagged edges that were happening at those faster rates of speed actually, I think, were because the computer was having issues with performance because it was doing both the rendering of this and the recording of video at the same time. So I found that you could actually push the speed settings up higher than I'd been able to in the video and still get a smooth output. However, that does depend on the settings that you've changed up in these sliders above, which again govern the way that the drawing looks. Certain settings will have more jagged outputs at higher speeds, and certain settings won't be as affected by them. So I would just play with this constant and see what you can get with your different drawings that you create. I found that in certain cases I could bump it up to like 4 or 5 and still get a pretty smooth output, but it really depends on the settings above and what else my computer is doing at the same time. The final thing that I'm going to show you just to streamline this network a little bit, and this is just a really small thing. We used a rename top here, or chop rather, here to rename this chop channel to T because that was the component or the variable within our function that this chop network was creating values for. You could also do the same exact functionality of that within the constant chop. If we, within our constant chop here, change this name from channel 1 to T at the very beginning of the network, it actually has the exact same function. It renames this chop channel, and then because these two are merged together in this math chop, it just keeps the name of the first input. And then finally, in our final speed null, we still have that T channel name. So that would just kind of simplify this network even a little bit more. So with that, we can actually get on to the modifications that we're going to make to this network. And basically, what those modifications are going to entail is adding a couple of different drawing modes to our chop execute dat. So the Spirograph has a variety of different plastic gears that interlock in different ways and can allow you to create different kinds of geometric drawings with them. And it turns out that the one that we created in the last video was just one of several different types of drawings that you can make. And behind those types of drawings are also mathematic formulas, just like in the last video. So in this video, we're going to cover how we can add those different drawing types to that original application we created so that we can have all of the different varieties of drawings that you could get with the original Spirograph. So without getting too far into the mathematical theory behind this, the function that we used for our original version of this program that we did in the last video is just one of several similar related functions that can plot these curves, which will give us that Spirograph style output. Spirograph toy had several different gearing systems that allowed for these different types of drawings to be made. And so to give our drawing program even more functionality and to enable us to draw some of those other types of output, we have to, or we're going to add those formulas into our Python code. And in a real basic sense, what this will enable us to do is instead of having drawings that have an outer edge that is circular, we can start to get different shapes. Like you can see here, this is drawing a star shape, and then This one is also drawing a similar kind of star asteroid shape. Um, and again, that'll just allow us to have a little bit more flexibility and drawing possibilities with our TouchDesigner program. So what we're going to do to start is set up a keyboard in chop, which we're going to use to be able to switch between the different drawing modes that we will add to our program. And then we'll work with the chop execute dat, adding in that new Python code and then enabling us to start drawing those different versions of the Spirograph drawings. So if we want to get started, we're going to set up that keyboard in section first. So I'm going to actually do a little bit of remapping of keyboard input right now because we're going to have 4 total different modes that we're adding to this, and I'd rather those modes be accessible via the 1 through 4 keys instead of the 1 and 2 keys starting and stopping our drawing and or resetting our drawing for the 2 key. So the first thing I'm going to do is I'm going to change the functionality that starts and stops our speed null from counting upwards. I'm going to shift this from the 1 key to the 0 key. I'm using a keyboard with a numpad, so that's at the bottom and kind of makes sense as a on-off switch. And then from there, I'm going to come over to our feedback loop that we set up in the original and change this from the 2 key to the 9 key. And then we have to make sure that we redo this chop reference because we no longer have the channel that it was originally referencing. And now if we bring this up, hit 9, we can clear it. And if we hit 0, we can start drawing again. So that's great. Now we can set up the switching system for the mode, and then we'll work on our Python code. So I'm going to bring in another keyboard in chop, and then we'll set up, we're going to bring in the 1, 2, 3, and 4 keys. So now that we have our keyboard in chop, we can use the logic chop to take those channels and combine them together into a format that'll be usable when we get to our chop execute dat. And all we're going to do within this is change our channel preoperator to radio button so that we can toggle which channel is on at any given time. Once you've set the radio button mode, you can come to combine channels and use either the lowest index or highest index on, it doesn't matter. And that'll take all of the channels and combine them into one single chop channel that goes from 0 to 3, which we can use to tell our chop execute dat which mode we are looking for it to be using. I'm going to put a null down, oops, not quit. I'm going to put a null down, and then actually I'm going to add a rename chop in between. I'm going to rename this chop channel to mode, and then within the null title field, I'm going to change this to read mode null. And now we have a switching system for those different modes that we're going to set up. Now we can actually come within our chop execute dat and make some changes to add those different drawing modes. Like last time, use a external text editor so that it's a little bit easier for you guys to see, and we will make the changes within there. So the first thing that I'm going to do is I'm going to grab that mode output from that chop channel and assign it to a variable at the top of this Python code. So what I'm going to do is set mode equal to operator mode underscore null, and then the channel name is also mode. So make sure you've got that exactly, and that will set the current setting that we find within that mode null to this mode variable within our Python script. What we're going to do with that information is then set up a series of if statements and say if the mode setting equals this number, then use these functions. If it's equal to a different number, use a different set of functions. And what we're going to start with is just setting up the basic function for the epitrochoid, which we essentially did last time. We're just going to make a little bit of modifications to this Python code so that it matches what we see on Wikipedia. And just to bring that up again, here's the epitrochoid function. The only difference between this and our original is that we are subtracting the second cosine section of that formula instead of adding it. So what I'm going to do here is first I'm going to put a comment which says that this is the epitrochoid, and then we'll set up our if statement. If mode equals 0, so basically if we've hit the 1 key on our keyboard, then draw us that default epitrochoid mode that we were using in our last video. So now that we've got our mode if statement set up, we have to make sure that we use the tab key to shift the position of these two variable assignments over so that Python knows that these are intended to be within this if statement. And then the second thing that we're going to do to modify these equations to match what we see on Wikipedia here is we're going to change these plus signs, which add the two components of our equation together, to minus signs so that those two components are subtracted. And that, again, is just to follow the formulas that we're finding on Wikipedia so that they're all consistent in their content. Great, so we've got that set up. Now we can copy and paste this and add our second mode. So I'm going to paste that and then shift this little note back in space. We're going to be creating our hypotrochoid function now, and the first thing we're going to have to do is change this mode number to 1 so that we don't double dip on our 0 mode. We make sure that the 2 key on the keyboard will give us a hypotrochoid instead. And then if we come to the Wikipedia page, here's what that drawing could look like with particular settings. The main difference with this function from our original function is that we have in our x function, we are adding the two sides together, and then within the y function, we are subtracting those two components from each other. Besides that, our radius values are also being subtracted, the radius 1 and the radius 2 parameters. So if we come into our function here, the first thing I'm going to do is change all of those radii being added together into radii that are being subtracted, and then once we change all of those to minus signs, we can add a plus sign for our x equation, which is the top one, and then that will give us the output that we're looking for. So that's it for those first two. The second, or the third and the fourth modes are actually in some ways a variant of what these two first modes are. So if we look at the diagrams here, we'll start with the epitrochoid. The point at which we're drawing in the case of the epitrochoid is a point within the second smaller circle. And if we look at the epicycloid, which is another option that we're going to set up, this point is actually locked to the edge of this second circle. And we don't have, if we're looking at our equation here, this value of p is actually just replaced with the lowercase r radius value instead. And that allows it to be locked to the edge of the circle. So in theory, if your p-value was set correctly, you could get the exact same output from the epitrochoid function as the epicycloid. But I just thought that since it's very simple to add a couple lines of code, and it'll allow us to experiment a little bit more, we can just add this as a mode that we can easily switch to via the keyboard. So before actually we continue with that, I'm just going to make sure to change this second if statement to an else if statement. And then I'll copy this first epitrochoid section and paste it below the hypotrochoid, and we'll make our modifications from there. Want to make sure that this is now called epicycloid because that's what this third mode is going to be all about. And then our mode will have to be have a value of 2 for this one, and then the main function or difference within these functions that I mentioned is we're going to change this p parameter to lowercase r, and that is it for the epicycloid function. In a similar fashion, the hypocycloid function is very similar to the hypotrochoid, except that instead of having a variable position from the center of this second circle, it's again attached to the edge of that circle. And so there's no p value within this equation. We're just replacing the p with a lowercase r. So I'm going to copy and paste this equation from the hypotrochoid section just because it's a modified form of that. We're going to change this to say hypocycloid, and then we're going to set the mode to 3. And then, as I said, we're going to remove the p variable and replace it with that lowercase r. Just make sure that this third if statement is rewritten as else if, and now we're actually all done. That is all we have to do in order to get those different modes. So if we come back to our drawing program, and let me actually just make sure that I save this first of all so it updates within TouchDesigner. And then we take a look at our output. Now that we've made those changes, what should happen is that when I hit the 0 key, that'll start the drawing, and I'm going to go ahead and clear the screen. So we're getting a couple of jagged edges here, and that's probably due to the speed at which things are happening right now. So I'm going to slow that back down again via our constant. So this is actually currently in the default drawing mode, and it's giving us output that we're familiar with. But if we hit the 2 key, we can now see a different drawing mode, which I'm going to try speeding up here just so that we can see the different way that this is outputting. So it's a little bit jagged, but you get the idea. Instead of creating an outer edge that was very circular, we're getting a more flowery shape. And if we start to modify these settings within our sliders that we set up last time and then clear it again, you can see that the way that it draws is very different, and we're starting to actually get that star shape that we saw from the Wikipedia article. And that's because we are in our second mode, which is the hypotrochoid mode. So again, that'll give you that star-shaped functionality from the original Spirograph that is even more distinct maybe than that first mode that we set up. If we clear that, we can try mode number 3, which is the epicycloid mode. And you can see in this mode, we're actually getting like a hard point at which the line is stopping at instead of smooth curves like we saw in our original. So you can create flower shapes with this one as well. Lots of different variations that you can make with the sliders. There's all sorts of different outputs that you can get from experimenting with our slider settings with this with these new modes. Finally, we'll take a look at the hypocycloid real quick. This one gives us those pointed edges on the outer portion of the drawing rather than on the inner portion that the epicycloid gave us. And with that, actually, we're pretty much done with this tutorial. I think that with those setting changes, you really get something that allows you to draw stuff that looks almost identical to what you can get with the Spirograph, and it gives you a lot more flexibility with your drawings. One thing that I wanted to mention before we wrap this video up here is if you ever are noticing that your drawing on your screen is taking up the entire screen space, or you're having portions of it cut off, you can start to modify the camera settings that we set up in the first video to either zoom in or out from the drawing. Because of the feedback loop, when you do this, however, it will modify the current drawing and not just zoom in on it. So if we take a look at this right now, because of the feedback loop, if I hit 8 on my camera, you can see that this drawing didn't change, but now it's drawing at an even smaller scale in the middle. So you have to clear your screen basically and start your drawing over. It doesn't allow you to zoom in or out of the current drawing because all of that is done via the top network and the feedback loop there. But I just thought I would share that info so that you can make the modifications that you need as you're creating your drawings. So, with that, as you start to work with this technique yourself and post the output of that to Instagram and other social media platforms, as I mentioned last time, use the hashtag tdspirograph so that we can start to see what different kinds of output people are able to get with this technique. I think there's a lot of room for creative exploration because we're involving so many different operator types that have so many different functions that we're not even covering in this video. And I think that everyone's going to have their own specific approach to this and be able to come up with some really interesting outcomes. I really look forward to seeing that on Instagram and other platforms. And as always, like and subscribe. I'm going to be continuing to make even more Touch Designer tutorial videos in this series, Another Touch Designer tutorial. If you want to kind of see what I'm up to on a day-to-day basis in between me posting videos, follow me on Instagram at Jack Delora, which is the same name as the channel that you're currently watching this YouTube video on. If you have any requests for content that you'd like me to cover in future videos, feel free to leave a comment below or send me a message on Instagram. I'm always looking for new ideas for content that you guys would be interested in. So feel free to reach out. And with that, we will end. I look forward to seeing you in the next video.